Okay, think about the oil field for a moment. For, well, decades, right? It ran on sheer grit, but managing those really complex operations often involved just mountains of paperwork.
Oh, yeah. Handwritten reports, maybe stuff stuck on a whiteboard, hoping to keep track.
Exactly. It's kind of amazing how much was handled manually.
Right.
But if you're in the industry, you know that's changing fast. Those old ways, they're becoming history.
Absolutely. The industry's always faced tough challenges, but modern operations, they've just gotten so intricate. Those paper systems just couldn't keep up anymore.
The need for something smarter, more responsive, it just became obvious.
Totally undeniable.
And that smarter approach,
Ah.
well, it's digital transformation. So today, we're doing a deep dive into how this is really shaking up oilfield services.
And we've got a great real-world example to ground us.
Right, we're focusing on B&B Roustabout Inc. Their story really shows how companies are using these tools.
Yeah, B&B highlights how, forward-thinking outfits are grabbing onto digital tools. It's not just about competing, it's about really excelling.
Exactly. So our mission here is to unpack how companies like B&B are using things like mobile apps out in the field, live dashboards with critical data, better ways to manage info.
All aimed at boosting efficiency, improving safety, which is huge, and just making smarter, faster calls.
Yeah, and we'll even touch on this interesting concept, the digital twin, sort of a virtual copy of physical gear.
It's fascinating stuff, and we've got some solid sources for this. We'll look at insights from Joe Carter at Twin Flame Group TX. He knows B&B's journey well.
We'll also explore how these intelligent dashboards make a difference in oil and gas generally.
Plus, a case study on a company called FieldEquip, and we'll dig into those predictive digital twins you mentioned.
Okay, let's get into it. Starting with B&B Roustabout, what really pushed them? What were the big reasons they decided to go digital?
Well, for B&B, according to Joe Carter, it was kind of a perfect storm of needs. First off, scalability.
Right, they were growing.
Exactly. As they grew, their old manual ways, they just became a bottleneck. They couldn't handle the volume, the complexity. They needed systems that could scale with them.
Makes sense.
Then, a huge driver was needing better insights, like understanding what was really happening. There was this lag, between field action and getting usable data back.
Yeah, you're flying blind almost, always looking backwards.
Precisely. Real-time visibility was another big one. Imagine managing multiple sites, crews, equipment, without knowing the score right now. Real-time data just gives you that immediate awareness. You can react quicker, more effectively.
And that feeds into safety and decisions, I assume.
Absolutely. That's the bottom line, really. Better, faster information means safer choices for the crews and, well, better decisions for the business, for profitability.
So how did they actually do it? What were the key parts of their digital strategy?
They took a really smart, layered approach. A big piece was mobile-first field ops.
Okay, what does that mean exactly?
It meant getting mobile devices, apps into the hands of the field crews so they could log tasks, do safety checks, report progress right there from the job site in real time.
Wow, okay. That must have killed a ton of paperwork right away.
Instantly. No more waiting for forms to trickle back to the office.
Huge efficiency win.
Definitely. And that real-time data capture, it directly fueled their live job costing and asset management.
Okay. Connecting the field data to the money side.
Exactly. Using platforms with GPS, they could track equipment locations, see how it's utilized, get way more accurate labor allocation, and that means much better margin forecasting.
So you know your costs almost as they happen.
Pretty much. Knowing where your stuff is and how it's working, invaluable for using resources well.
That's like a live financial picture instead of waiting weeks for the tally.
We got it. They also really focused on streamlined communication.
Getting rid of the phone tag and endless texts.
Kind of. Instead of that messy mix of calls, texts, emails, they brought in centralized apps, connecting everyone, field guys, dispatch, managers seamlessly.
Reduces confusion, make sure everyone's on the same page.
Big time. Less chance of miscommunication. Everyone gets the latest info. You can imagine the time saved, the frustration avoided.
Oh, yeah.
And the final, really critical piece, data-informed decision-making. Those live dashboards, the reporting tools they set up, they gave leadership a near real-time view.
Because they could actually use the data coming in.
Right. Make proactive tweaks to schedules, reroute crews if needed, boost profitability based on actual facts, not just gut feel.
It's interesting. Joe Carter emphasizes that B&B saw this technology as enhancing their strengths. right? Like the grit, the reliability, the expertise they already had.
That's such a key point. It wasn't about replacing their core values.
Yeah, not throwing out the good stuff.
No, it's about layering tech on top strategically, making those existing strengths even more powerful in today's world. Successful digital transformation often looks like that.
He also mentions their goal, becoming leaders in safety, efficiency, operations out in the Mountain West. And he frames it as being bold enough to evolve.
Yeah, that really captures their mindset, doesn't it?
It does.
And it points to a bigger truth in oil and gas now. You have to keep improving, you have to be willing to adapt. It's not really optional anymore if you want to lead.
Okay, so B&B is a great case study. Let's broaden out now. These intelligent dashboards, these central data systems, how do they really help the bottom line across the industry?
Well, fundamentally, they turn this massive flood of raw data into something clear, something you can actually act on, and quickly.
Moving beyond just collecting data to actually using it.
Exactly. Intelligent dashboards, good data management, they let companies shift focus. Instead of just gathering info, they're using it day to day to get better.
And one huge area is tackling lost production.
Right.
That's always a costly problem.
Oh, absolutely huge. These systems allow a much more proactive stance, monitoring key production numbers in real time on a dashboard. Field teams can spot weird spikes, sudden drops, things that signal a problem brewing.
Like an early warning system.
Precisely. And downtime in oil and gas, I mean, the costs are staggering. Expenses keep piling up even when nothing's coming out of the ground.
Right.
So catching those issues fast, acting quickly, incredibly valuable. Often that lost production, it's just gone. You can't get it back. Imagine the savings if you minimize that downtime.
Okay, so immediate intervention saves real money.
Definitely. And it's not just about production volume. Lifting cost dashboards are powerful too. They let you visually compare operational costs across the whole company.
Making it easier to spot where money might be leaking out.
Exactly. And what's great is these dashboards can be designed so even folks without a deep finance background can understand them. They can quickly see where spending looks out of whack.
So it kind of democratizes that cost information.
Yeah.
Empowers more people to flag inefficiencies.
That's a great way to put it. Yeah. The focus shifts, right? From the painful process of generating endless spreadsheets and reports.
The spreadsheets.
Right. To actually analyzing the results shown on the dashboard, pinpointing where resources might be wasted or where processes could be cheaper, it just leads to smarter decisions everywhere.
And it gets rid of the chaos of relying on, like, dozens of static, probably outdated spreadsheets.
Oh, that's a massive benefit. Spreadsheets are old news the second you save them. These integrated systems, they're live, clear, concise views of what's really happening, cuts down redundancy, reduces errors.
Much easier to see the real picture.
Yeah, there was that example mentioned, like a simple dashboard view highlighting issues with demulsifiers or corrosion inhibitor pumps not working right.
Things that might get buried otherwise.
Totally. What could be hidden deep in spreadsheet tabs suddenly becomes obvious on a good dashboard. Allows for quick action.
It's like the system itself is pointing you to the problems.
Exactly. Making the data work for you, serving up those key insights without hours of digging.
Okay, let's pivot to a specific example of this tech in action, the FieldEquip case study. What's the story there? What can we learn from them?
FieldEquip is a really interesting one, especially for chemical solutions in shale fracking. They worked with a private service company, one that provides these specialized chemical treatments using mobile trailers.
Okay, so smaller, specialized units out in the field.
Right. And a big goal for this service company was to give their big clients operators like BP real-time visibility, data coming right off those mobile units.
That makes total sense. Those big operators managing complex fracs, they'd want that live data feed for monitoring, for making quick adjustments remotely.
Absolutely. But this service company had some real hurdles. They needed real-time decision-making, often way out in remote spots with, spotty internet.
Yeah, low bandwidth is always a killer.
Always. And just generally, they knew they needed to embrace digital transformation to stay competitive.
So what did FieldEquip bring to the table? What was their solution?
It was a few key pieces working together. They used their FieldEquip data gateway, that was the link, the IoT connection, to the PLCs on the trailers.
The controllers running the equipment.
Exactly. Stuff from Emerson, Allen, and Bradley, common brands. This gateway let them stream data in real time up to FieldEquip's cloud platform called EquipConnect.
Okay, so bridging the gap from the physical gear in the field to the cloud for analysis.
You got it. Once the data hit the cloud, EquipConnect analyzed it. Then the insights came back down via mobile apps, web portals, easy for the service company and maybe their clients to see.
And they included alerts, too.
Yeah, multi-channel stuff, texts, emails, push notifications, making sure critical info got to the right people fast.
So what were the results? Did it work out for the service company?
Yeah, pretty impressive outcomes. They got reliable connectivity to those chemical units, which were basically isolated before. It didn't matter which PLC brand was on there.
Nice.
They got real-time cloud access to critical data. High reliability, too, like 99.9% uptime reported on AWS. And importantly, it was a managed SaaS solution.
Software as a service, meaning less headache for them.
Right. Minimal ongoing operational costs, minimal maintenance burden for the service company itself.
That sounds like a big win. Better data, reliable system, without breaking the bank on overhead.
Exactly. And another key point was cost effectiveness. Solutions from the really big industry players can be super expensive, potentially out of reach for smaller or mid-sized service providers.
Right.
FieldEquip offered something much more affordable, both upfront and ongoing.
So it makes this kind of IoT tech more accessible, not just for the giants.
That's a really important takeaway, yeah. And their IoT Edge Gateway, the device in the field, it was smart. It had data caching built in, meaning even if the internet connection dropped out temporarily, super common in remote areas, right?
Oh, yeah.
The data wasn't lost. The gateway stored it. Then, soon as connectivity came back, zap, it sent the cached data up to Equip Connect for analysis, visualization, alerts, everything.
That's clever. Handles the real-world connectivity issue.
Absolutely. Keeps the data flowing, keeps the insights coming, even when the network's shaky.
This all definitely points towards operations becoming much more proactive, much more data-driven. Okay, let's shift gears again to something even more cutting-edge. The predictive digital twin. What exactly is a digital twin in this energy context?
Okay, so at its heart, a digital twin is a dynamic virtual model, a really sophisticated software replica of a physical thing, an asset, or even a whole system.
Like a computer simulation.
More than just static simulation. It's constantly updated with real-time data from sensors, other inputs, and crucially, it evolves right alongside the physical asset through its entire life. Design, build, operate, retire.
A living virtual copy.
That's a good way to put it. A living, breathing virtual counterpart. And this is especially valuable in industries like energy where assets are super expensive and last a long, long time, decades often.
Right. Big capital investments.
Exactly. So being able to extend the life of that pricey equipment or predict and prevent unplanned downtime, that translates to huge savings.
Unplanned downtime costs are astronomical in energy.
They really are. And that's where the predictive digital twin really shines. It's not just mirroring what's happening now. Its main job is to anticipate problems, predict future behavior, help you optimize performance.
So you're using the virtual model to see the future, essentially, to head off trouble.
That's the goal, yeah. Traditionally, you collect sensor data, analyze it after the fact, understand what happened or what's happening currently.
Looking back again.
Right. But if your systems are remote or super complex, or you need to figure out what might happen under future conditions or unexpected events, just looking at past or present measurements isn't enough.
You can't put a sensor on every possible future failure point.
Exactly. You need predictive data. And that comes from smartly combining real-world measurements with advanced simulations.
Okay, and the engine behind that is something called predictive engineering analytics.
Correct. That's the discipline. It blends sophisticated engineering simulations, things like computational fluid dynamics, CFD for fluid flow, and finite element analysis, FEA, for modeling stresses in materials. It blends those with smart data analytics and reporting.
Can we make that more concrete? The material used a heat exchanger as an example.
Yeah, good example. Heat exchangers are everywhere in energy power plants, refineries, chemical plants. Their job is just transferring heat efficiently between fluids. Critical pieces of kit.
Right.
Now, traditionally, you might monitor the temperatures going in and out, make sure it's working as designed.
Seems logical. If temps are off, something's wrong with the heat transfer.
True, but just knowing the current temps doesn't tell you the whole story about the equipment's long-term health, its structural integrity.
Oh, okay.
Like those temps might not reveal the cumulative stress the metal tubes have endured over years, or give you a reliable guess on its remaining useful life. You need deeper insights than just temperature.
Okay, so how does the predictive digital twin provide that deeper insight for the heat exchanger?
It starts by building a really detailed virtual model. Yes, you feed in the real-time temperature sensor data, but then you use CFD simulations to really understand the intricate fluid flow inside those tubes.
Okay, modeling the flow patterns.
Right. Then you use FEA, that stress analysis simulation, to model how stress is distributed within the tubes, especially where heat transfer happens. By correlating those simulated stresses, particularly in critical spots, with the actual measured
You
temperatures.
start connecting the dots between temperature and potential stress problems.
Exactly. You're using simulation to fill in the blanks that sensors alone can't see. And then comes a crucial step for making it practical, developing a reduced order model.
A simpler version.
Sort of. Think of it as a highly optimized, super fast version of the full complex simulation. You train this reduced model using tons of data from those detailed simulations. Once it's trained, it can run analysis much, much faster, basically in real time using the live sensor feed.
Okay, so you build the complex model, use it to train a faster one.
Mhm.
Then what can you do with that fast model in day-to-day operations?
So you feed the live temperature data from the real heat exchanger into this trained reduced order model, and it can instantly assess the stress response inside the unit.
Wow.
This gives engineers an almost real-time updated assessment of the heat exchanger's fatigue life. How much longer can it safely run?
That's huge for maintenance planning.
Absolutely. It lets you make informed calls about proactive maintenance, what repairs are needed, maybe even if you can safely extend its life beyond the original design specs. Huge economic implications.
So from a simple temperature reading, the twin gives this incredibly rich picture of health and future risk.
That's the power of it. And the material rightly stresses this is a life cycle concept. The engineering data from design and manufacturing. It's not just filed away. It's used to build and refine the twin over the asset's entire life, making it smarter and more valuable over time.
It really sounds like this requires much more collaboration, more data sharing between operators, equipment makers, tech providers.
That's a really key insight. Yes. Operators running the gear, the manufacturers with the deep design knowledge, the tech companies building these twins, they all need to work together much more closely to really unlock this potential.
It feels like a shift towards a more integrated, data-centric ecosystem for managing these critical assets.
Exactly. And, while we focused on the heat exchanger and structural integrity, these predictive twins have potential way beyond that. Optimizing production, improving safety protocols, lots of applications.
Different simulations for different needs, I guess.
Right. The right simulation depends on the life cycle stage, the specific questions you're asking. But that predictive engineering analytics piece, that's the core enabler for getting real value from digital twins in operations.
This has been, wow, a really insightful deep dive. Digital transformation is clearly reshaping things. If you had to boil it down, what's the single biggest takeaway for our listeners?
I'd say the core message is that digital transformation, using tools like mobile field ops, smart dashboards, these predictive digital twins, it's not science fiction anymore. It's becoming essential for success, for sustainability in oilfield services.
It's enabling better efficiency, better safety.
Huge gains in efficiency, major safety improvements, and just fundamentally better data-driven decisions across the board.
And it's not just about grabbing the shiniest new tech, is it?
No, absolutely not. It's about strategic integration, using these tools thoughtfully to boost your existing strengths, become more agile, and just adapt effectively to how complex the energy world is now.
Like Joe Carter said, being bold enough to evolve.
Exactly. That sums it up well.
So here's something to chew on. With the energy sector facing increasing complexity, increasing demands, how might this ongoing fusion of real-time data and predictive analytics truly reshape how we tackle operational challenges and long-term asset management in the coming years? Think beyond just the examples we hit today. It really feels like we're stepping into a new digital era for the oil field, doesn't it? Powered by innovation,